So you should all have a supplemental note sheet out. It should be filled out also. The first slide here is just going over, making sure you have what you need to have on it in preparation for tomorrow's quiz and next week's test. Okay? So let's talk it. Step 0. Step 0. Literally, you guys are reading this. Simplify. You guys are literally have all of this in front of you. Step 0, we need to simplify the function if possible. Okay? Right? Even if it's not simplifiable, we can still get all of our factoring in and factoring done. Okay? Right? So we get that out of the way there. Step 1. Domain and vertical asymptotes. How do we go about finding domain and vertical asymptotes? Denominator equals 0. Okay? We set our denominator equal to 0. That gives us our restrictions in the domain. That gives us our vertical asymptotes in the on the graph. Okay. Step 2. Horizontal asymptote. Whoa! What happened there? It kind of jumped on me. It's one of those days with BenQ, I can see. Okay. Horizontal asymptotes. How do we go about finding horizontal asymptotes? Degree. What's my 3 comparisons? What? Tap the brakes. Big over small is what? None. Okay. But what do we have to look out for on that one? Okay. Next one. So y equals 0? You started with y equals and then went to words. Yeah. Okay. Okay. Love it. Okay. Step number 3. How do I find the y-intercept? We just plug in 0. Okay. Somebody other than Ray? Step number 4. X-intercept. How do I go about finding the x-intercept? That's numerator equal to 0. Okay. Step 5. Holes. Okay. What do I need to remember with the holes? Set the what? Whatever we factored out in step 0. Then do what with that? After I set it equal to 0 and I solve it, what do I do with it? And that gets me the y part of my hole, right? So if I factor something out in the first step, plug that in. What if I factor out an x in the first step? Factor out the top and bottom. And we've had one. We had one of those on last week's quiz. whole, right? It can't be both. Which one's got precedent? The whole. The whole has more clout, more precedence, more power than an intercept. Right? So it can't be listed in both. Right? It can only be listed in one. Okay? And it would be listed in the whole. Step 6. Slant asymptote. How do we find the slant asymptote? We do the division, yeah? We do the division. Yeah? And then lastly, step 7. Extra points, okay? And we should have points in all of our zones, right? Remember, we zones it with vertical asymptotes. Okay? All right? So that should be your supplemental note sheet now. Okay? I'm guessing yesterday you also went over this again too, but it also helps to go over it a couple of times so that it really just does become supplemental. It's not, you're just doing it. Okay? All right, first example of the day. Go for it. Sketch the graph, find any intercepts and asymptotes and holes, and list them all out, and do all that fun stuff. Okay? Go for it. All right, so we planned our work. That's on our supplemental note sheet. Now let's work our plan. Step 0. Simplify it. Can the numerator be simplified in any way? What does it factor to be? Denominator, can it be factored in any way? What? Anything cancel out? No. So really the only thing that we've done there then is we've made our subsequent steps easier. Because we've got all of our factoring done. Okay? Alright? So nothing cancels out. So this is the function that we're gonna graph with. Okay? Alright. Step number 1 then says what? Domain and vertical asymptote. So what is the domain of this function? Okay. Which makes my vertical asymptotes be? Those are numbers. Can I write them as, could I write that as x equals plus or minus 2? Nope, I got to write those out separately because it's 2 separate lines. Okay? Okay? So let's put those on our graph. Remember, those go on dashed. Okay? Can I cross those 2 blue lines? No, I can't cross those. Okay? All right? Good to know. Step number 2. Horizontal asymptote. None, right? Because the degree on the top is 3, degree on the bottom is 2. That says none, but because it's a differing by 1, it's a none with an asterisk. Okay? Step number 3. Y-intercept. I plug in 0. Is it going to be easier to plug in 0 in my original function or in my factored function? In which one? In the original, right? Because anything with an x in my original goes away because it's 0. So this would be 0. This would be 0. That means I get 0 on top. This would be 0. That means I get -4 on the bottom. So my y-intercept is 0, 0. Step number 4. X-intercept. What do I do to find my x-intercept or intercepts? Numerator equal to 0. So that means x times x plus 3 times x minus 3 all has to equal 0, which means x has to equal 0. So that means I've got 0, 0 as an x-intercept. Then I've got x plus 3 equals 0. That means that x equals negative 3. So that means I've got negative 3, 0 as an x-intercept. 1 and 2 and 3. Then I've got x minus 3 equals 0. That gives me x equals positive 3. That means that 3, 0 is an x-intercept. Step 5. Holes. Is there a hole? Step number 6. Slant asymptote. How am I going to do this slant asymptote? We got to use long division because the denominator is not linear, so I can't use synthetic division. So I've got to go back to our old friend. This is why we learned it, long division. So outside I've got x squared minus 4. Inside I've got x cubed plus 0x squared minus 9x plus 0. There. Multiply first by x. Change my signs. This one goes away. This one becomes negative 5x. Right? Is there any way to multiply x squared and it becomes negative 5x? Nope. So then this is going to be plus negative 5x over x squared minus 4. Okay? So remember, within step 6, finding that slant asymptote, first we have to do the division. After we do the division, what do we do?
Remove the remainder.
What do we do with the remainder?
Remove.
Remove it, get rid of it, toss it, hit the bricks. It's gone. And what's left over is our slant asymptote. So our slant asymptote would be y equals x. Yep. Okay. So then we can go to our graph. And we can put in our slant asymptote. I'm going to reapply, for me, because it went over the top, I'm going to reapply my x and y intercept of the origin. Right there. Okay. So we've got 3 zones, yes? Do I need to add in points? Do I need to find more points in my left zone? If you think you do, you do. I don't think we do. Because I've got 1 point in there already, so I know I can't cross my vertical asymptote, and I know I've got to end up along my slant asymptote, so I think that there's enough points in there to do that one. Yes? Okay. What about my far right zone? Do I need any more points in that one? I don't think so, because again, it can't cross the vertical asymptote, and it's got to end up along the slant asymptote. So I feel we've got enough information there to do that. However, that middle zone, we should probably do some more work in. We should probably find some points in that one. Okay? So I'm going to try +1 and -1. Okay? My function, again, was x cubed minus 9x all over x squared minus 4. Okay? So if I plug in 1, 1 cubed is 1. 9 times 1 is 9. 1 minus 9 is -8. 1 squared is 1. Minus 4 is -3. -8 divided by -3 is +8/3, which is +2 and 2/3, which would be right there. If I plug in -1, -1 cubed is -1. 9 times -1 is -9. -1 minus -9 is +8. -1 squared is 1. Minus 4 is -3. That would be -8/3, which would be -2 and 2/3, which would be right there. So the middle section goes through like that. Questions, comments, concerns, clarification? Let's try one more. You try this one. Good questions. You guys were asking good questions of each other. Okay? So, step number 1. Simplify. You have your supplemental sheet? Yeah. Do you feel that it would be easier to do if you had it out? All over x minus 4? Okay. Then what did you do? Love it. That's good. Okay, so my new function is what? Just x plus 4, right? Go over 1, but do we ever write any over 1? No, no. Okay. All right. So, somebody, fire me off. What's the domain of this function? All real numbers. X cannot equal 4. Okay. Now, here's where it gets all cray-cray. Vertical asymptote? Whoa, whoa. See, I told you, it got all cray-cray. Even the BenQ board said, wait a second. So what's my vertical asymptote?
4.
None. Why none?
Because 1 cannot equal 0.
Because there's no denominator. Okay? So there's no denominator. 4 is a number, just so you know. Okay, vertical axis are lines. Okay? So, okay, but that's not gonna work because so we use our original function for what? Domain. And we use our new function for everything else after that. Okay? So vertical asymptotes, none. Horizontal asymptotes, none. But it's just going to be in the function again, right? Right? Because there's no fraction. Right? So it's not even an asterisk type 1. No, exactly. Y-intercept. What's my y-intercept? 0, 4. X-intercept. What's my x-intercept? -4, 0. Okay. What's next? Hole? Do I have a hole? So I take 4, right? Because I factored out x minus 4. I set that equal to 0, so that's going to be x equals 4. I plug that into my new function, and that's going to give me 4 plus 4, which is 8. So the hole is going to be at 4, 8. Okay? Slant asymptote is none, right? Because I don't have a fraction. My new function is not a fraction, so it's none. Okay? So I got a y-intercept of 4, that is 2, and that is 4, that's right there. I got an x-intercept of -4, that is 2, and that is 4, that is right there. I've got a hole at 4, 8. 2 and 4, 2 and 4, right there. I got no slant asymptote, so I'll draw it in nice and straight and nice and pretty. What's this one? Still want that one. Oops, tap the brakes. Can't do it. Gotta do this one. Ah. Why? Why is it not there? Because that's our line. That's our function. There we go. Again, I remind you that you have the cream-colored sheet is due tomorrow. Tomorrow you have a quiz, summative quiz. Okay? Friday, Independent Learning Day, is the cream-colored packet. Again, I apologize for making them the same color. I couldn't remember what this week's color was, so I just grabbed the first one I saw. Okay. Friday's Independent Learning Day is the packet. You should get at least half of the packet done on Friday for your assignment. Okay. Then next week, Monday, we have a couple of more graphs that we want to go over. Next week, Wednesday, we'll have a review in-class activity. And then next week, Thursday, is your Unit 4 test. Okay? Good times.